Okay, this is the latest video in this series about making a strategy game in C++ with DirectX. I should actually launch it. I should have already launched it. What am I doing? It's this game. It's not a promo for this game, but in fact, I'm not sure if yeah, a lot of this is not set up right actually at the moment. Anyway, yeah, it's a space auto battler game. This is the kind of thing that we're talking about. I think I've turned all the volume down, haven't I? Yeah. Anyway, it's this kind of thing. And this is actually quite relevant. I need to show a little bit of the game for this episode because I'm going to talk about graphics engines. This is a very simple, small battle in my game and without much stuff in it. Let me try and see if I can launch a much bigger one. I don't know. Anyway, there's a lot of stuff like this in the game. So I'm drawing a lot of stuff in the game. Okay. This might crash actually. Oh no, let's just zip ahead. So it's this sort of a thing. And the reason I'm doing this series is a lot of people expressed an interest in knowing how you would do something like this, but not using Unity or Godot or Unreal. So the engine for this was coded by me from scratch for this game. Even though I've made loads of games, I just coded a lot of stuff from scratch again for fun, because it is actually quite good fun. If you are minded to like do a lot of technical code. But the trouble is, and you'll know me banging on about this if you've watched the other videos in the series, is that like everyone uses Unity and Unreal, or the assumption is that everyone uses Unity and Unreal. So there's not really that many people talking about how to do it all from scratch. Okay, and you can do all this from scratch. I mean, I'm not Jonathan Blow. You know, you can code all of this. It's not like some incredible thing that only the 10 people at the heart of Unity and Unreal could possibly code a particle system or lens flares or whatever. You can do all this, right? And it doesn't take 10 years either. It's not that hard. And I will explain how to do it. So for this video, what I'm going to do is talk about graphics engines, which I've kind of like touched on, but I haven't really explained what's involved. So I'm going to close this and get a code. This is my code for whatever I was last working on. And anyway, so I'm going to go through what you have to do to have your own graphics engine for a 2D game. I don't make 3D games for two reasons, partly because then you kind of need to write a lot more code. I'm not interested in it. I don't like. I've worked at big studios on like 3D games. Not doing engines. We're not doing graphics engine stuff. We're not much, and it just doesn't interest me. And I for whatever reason, I just kind of I don't know what it is, but I don't like it. But also, kind of like weirdly, really. I mostly prefer 2D games. I play Battlefield. I play a lot of first-person shooter games, but I prefer to make 2D games. I prefer to design 2D games. So what I'm saying is, if you want to do some 3D game and you're here to see how to do a graphics engine, it's probably still helpful and interesting, but I'm not covering all of that kind of stuff. I am covering how to really push 2D, and I use DirectX 9, which is slightly because I'm just used to it, but you can do a lot in 2D with DirectX 9, and I use Visual C++, but I try to talk more in terms of concepts than individual code. So if you're coding in Java or C# or whatever, hopefully it's still of interest, because very few people are open enough to sort of go, look, here's my graphics engine, because it's a lot of work, and I guess people think, I don't know, you'll nick their code, but I don't worry about it. I'm kind of semi-retired anyway. So let's talk about DirectX and what a graphics engine is, really, because some people just might not really know what that means. So a game engine is a big, huge thing. This stuff on the left here is all of my code for my like base engine there. But that's just part of it, really, because all of the user interface stuff is here in a folder called base for some reason, and it's got like subfolders, and so there's loads of extra stuff in there. So there's a lot of code in a game engine, but a game engine will include like animation and file loading and multi-threading and like profiling and saving and loading. There's a lot of stuff in a game engine, but what I am talking about specifically in this next hour or less is the graphics engine. So what does that really mean? Ultimately, the graphics engine just draws stuff, right? Okay, and really, it's kind of simple until you get to shaders. Now, a lot of people who talk about graphics engine talk about nothing but shaders. Here's my shader. Here's the shader that does this. Here's my shader. Here's another shader. Here's the shaders. You can do a lot of stuff without shaders. You can make, like if I took all of the shaders out of this game, some of the effects wouldn't be quite as cool, but 95% of the graphics engine would still be there. You don't have to write shaders to do everything, and you certainly don't have to use a really like arcane language to do shaders. Shaders are not assembly language stuff. Let me just I'll find a shader from the game, and I'll open it and I'll show you it just to show you what I mean. This is the most complicated one. Let me just open with TextPad. Okay, right, check. Can you see that? This is like the most, well, it's probably not the most complicated, but it's one of the most complicated shaders in the game. It's not that complicated, right? It's not rocket science or anything like that. It's a little bit kind of, for me, the hard bit was learning how to interface stuff like this, which is a shader to do a specific thing to do with compositing light maps that I use in my game. But the difficult bit is knowing how all of this relates to code written in C++. Shader language really looks like C++, right? Okay, so it's not particularly scary, and if there are FX files, which is the format that I use for shaders, they're normally just like in the folder for a game, so you can just open them and see what people do, because the source code is just there, right? They get compiled at like runtime, whatever. But what I'm getting at is that a graphics engine is not just shaders, and don't be freaked out by shaders because they're not super hard. I could do another, if people are interested, I could do another thing just about the shaders I use and how to use them. Anyway, so yeah, don't obsess about shaders. So with DirectX, basically what you're doing is you are drawing triangles on the screen, right? And in DirectX and then in most APIs, that's called a primitive. So you're basically drawing either a triangle or a group of triangles. If you do two triangles together, you can get a rectangle. And then, or if you draw a fan of them, you can get a circle, and everything in between and extended from that. But there are not actually many API calls in my engine. I have this class which I call D3D engine. You might think, but Cliff, you're doing 2D, but I use 3D hardware, so I'm using kind of like hardware acceleration, as it were, to draw 2D. So, and yes, it's not named the same naming convention as any other part of my engine because I am a confused old man who keeps changing his mind. Anyway, so what really is there to a graphics engine? Well, ultimately, the things that matter are these two things. So you have an object, a direct 3D object, which you kind of create right at the start. And then you create a device. And you use the object, I think, to create the device, as I recall. Anyway, the device is basically the video card. And when you see this horrible syntax here, LP Direct 3D Device 9, that just means it's a pointer to a device in DirectX speak. So, yeah, the device is sometimes called the adapter, but it's basically the video card. So when you initialize your engine, you're kind of deciding what video card you're going to do everything with. I don't think you can use both at once under any circumstances. So if you have multiple video cards on the PC, you have to make sure you get the right one. And I have some code that lets you pick the right one. It's called adapter ordinal. Horrible syntax, and you can find out which one it is here and stuff like that. But the two things that really matter is the pointer to the Direct3D object and the device. Once you've got the device, you forget about the object. The object is irrelevant. The device is what you use to draw everything, and almost all of it comes down to this one function. There's a lot of code here, right? But basically all I'm really doing is this function, draw primitive user pointer. Okay, so I'm just going to show you that and then we'll talk about how we get there, because it's basically just a really simple wrapper for a DirectX call. And what this function does pretty much everything in the entire game that doesn't use a vertex buffer. They're a separate issue. So it's basically saying, what kind of primitive is it? Is it a triangle? Is it a bunch of triangles? Is it a triangle fan or strip? How many of them are there? And give me a pointer to all of the vertices, all of the points. And then you have this thing that's absolutely irrelevant in my case. So it's actually at the raw metal, as it were. Your graphics engine is really just a wrapper for the Direct3D device and this function. That'll be called everywhere by everything. In fact, I think if I can do it, does this actually work well? Yeah, look, here's all other parts of my engine that are calling it, right? So I call that a lot. There is something else you do with vertex buffers because they're done in a different way. But most of the stuff that you would do in your average indie 2D game is not vertex buffer stuff, but I will come back to that. So there's a lot of code here. If you see me scrolling up here, you sort of think, well, there's a lot of code and you're glossing over a lot of it, right? A lot of it is just stuff I've accumulated over the years, right? Like, look at this. This is a huge function that just takes a DirectX error message and gives me a nice English version of it. So that's part of it. And this is the initial setup that I do. And I'm not going to go through all of this stuff individually because you can just like Google it, and it's pretty much everyone is doing the same stuff when they set up their graphics engine. Okay. So for example, this modulate between texture and diffuse, that's just saying that, yes, when I draw something, I am drawing it using a texture. So I want the pixels to come from the texture, but I am multiplying that by the diffuse color. So you can take a texture and you can change the color of it separately. And that's, of course, that's what everyone does, right? Okay. And a lot of this stuff here, like that's the filtering of stuff so you don't get anything blocky. So the individual texels are filtered nicely as you zoom in and out of stuff. This makes sure you can't get U and V values that are nonsense. It's all pretty simple stuff. This is just showing that, yes, we can take alpha. Well, all of this together really is saying we take the alpha values of a texture, but we can also add our own alpha values. And if you don't have that, you can't fade things in and out. So pretty much any game engine that uses DirectX 9 will have that in it, right? And this is saying we're using fairly standard transformed and lit vertices. In other words, I am telling the graphics engine where on screen a triangle is and what color it is. I'm not using their built-in camera and matrix stuff to do that. So anyway, I mean, there's a lot of DirectX code, but the bit that kind of matters is initialize. Okay, so with initialize, here you go. I'm creating that Direct3D object. If you don't get that, something bad has gone wrong, and you just quit. I am then getting the specific graphics card here. I'd allow you to pass in a number to get a particular one. I then ask the graphics card that I'm talking about what its name is, what the driver version is, and its description. You can get all this stuff with a simple API call there. And I dump that to a debug file. And you should do that in a debug file because what I find quite helpful is someone says the game crashed under certain circumstances. I say, send me the debug file. So I get everything in the debug file, and at the start of the debug file, I know exactly what graphics card they got. So I know also if they're using the wrong graphics card, if they got two. And I also know the driver version, and I can I could Google that and go, yeah, I think you need a new updated graphics card. There's some stuff here where I just check that certain capabilities are present in the card, but a lot of it is nonsense these days because they all do. And there's just a bunch of stuff you have to set up where you have to sort of say, yes, I want a back buffer, because we draw everything to an off-screen surface called the back buffer, not the screen. And then when we finished, we just flip, and that becomes the screen, and then we draw to the back buffer, and then that becomes the screen. And you kind of flip these things. That way you're never drawing on the screen when someone's looking at it. So you don't get this thing called tearing. But again, a lot of this stuff you can just flip in Google, and it's quite simple. And we are using hardware vertex processing, which of course you are, because every graphics card in the universe now does all of this stuff. And there we go. Setting up that is almost all of setting up DirectX. This one function here, and a lot of it is debug checking, right? That one function is basically how to set up DirectX in order to do a 2D game. A lot of the other stuff in this is like just kind of like helper functions and obscure stuff. I'm checking that we support certain models of shader, which again these days everyone's got version 3 at least, so who cares? But I check that you've got at least 2 and 3, and I've got all this kind of other stuff for really old graphics cards, but you probably don't need it anymore. This is one other function that is useful, which is set render target. So when I'm saying we're always drawing to the back buffer, sometimes I'm not. If I'm drawing light maps, I'm drawing it to another screen, and then I'm blending that with the back buffer. Well, I'm blending that with another off-screen surface actually together. So you kind of need that, because if you want to do interesting effects, a lot of the time you're not rendering to the back buffer, you're rendering to some other surface that you're then going to composite together. Actually, if I don't know if I've mentioned this, I will show you what that looks like, and then I want to move on a little bit. I don't want to get bogged down in individual API things because they're very Googleable. Okay. I just want to explain that last comment about rendering to different buffers. So if I get into that big battle again, just so a lot of stuff is going on, if I can get a cruiser to blow up, that would be ideal. But they take a bit of blowing up. So I'll just skip forward a little bit. Ah, balls, missed it. Classic. Oh, have I got one there? I maybe don't. So if I do, is it L? Yeah, there we go. These are, I may have shown this before. No, I haven't quite got it, but I'll let it run. So this is the actual screen up here in the top left. This is how I draw everything. I then draw light maps here. I'm drawing this to like a sort of distortion buffer thing. There you go. You could see that there. Whenever you see something on this funny coloured, very specifically coloured thing there, that is something that is distorting the screen around it. See these little things down here? They actually distort space around them. I can't remember what this is. I think this is like a smaller version of that I then composite. Did you see over there that there was like a shockwave? So all of these things here, I draw to these screens separately, and then I composite all of them together, and it looks like this at the end. So these are different render targets, okay? And a render target is just a texture that you create, an empty texture that you create that is basically somewhere else you can draw to. And actually, there's a real cool one here. That render target there, that is used for certain particle effects. So I've got this handy animated like particle wavefront that I use for other stuff. And I'm really not pushing it at all. I mean, like, I've done games where you've got like 8 of these. So it depends. So yeah, you need the capability to set a render target. But again, that's, that kind of stuff is quite simple. When you create a render target, you create a texture with special flags on it. That's all you do. I've probably got a function for it called create render target, right? Set render target. I must have create render target. I don't know where. It'll be on here somewhere. I'm probably staring at it. There you go. Create render target. Easy peasy. It looks more complicated than it is, but yeah, it's actually no big deal. Anyway, what if you get nothing from that intro other than the fact that it's perfectly doable to write a graphics engine, and you can do it all in one CPP file. Then that's good, because people overcomplicate things. And when you look at this, you're thinking there's a ton of code, right? But a lot of it is just like little helper functions that shouldn't even be here. And in fact, I created a whole new class called engine helpers. And what that does is it draws rectangles, either filled or outlined, because I realized I was doing this a lot in my in places like this. And this is in the graphics engine, right? And I realized that is actually bad software engineering and bad code organization. I am a big believer in the fact that when you have a module, a class, whatever, it should do what it does. Don't stick other stuff in. Create a new class that does that stuff. And this here is an example of me not doing that. This is out of date old me that thought, well, I could just stick functions in the engine that frame a rectangle, okay, or that fill a rectangle, or that render a circle. This is all rubbish, and it shouldn't be in here. I should move all of that to engine helpers. The reason I don't is I probably call it thousands of times. I don't want to change it all. But don't be like Cliff. Be organized, okay? So really, all that your engine code, your graphics engine code should do is, for DirectX 9, create the object, create the device, initialize the device, and have a wrapper function to actually draw a primitive, or to set a render target. There's a few other things I do. I clip viewports. So in DirectX, you can clip a viewport. Normally, the viewport is the screen. So you draw anything, it appears on the screen. But you can have a rectangle, which I can't, too stupid to do a rectangle. You can have an arbitrary rectangle on the screen, clip the viewport to that, and then draw stuff to it. And pixels outside that that viewport, it's got to be a rectangle, will be thrown away. And the reason you might want to do stuff like that is if you're trying to fit stuff inside a box. If you're trying to do like a video camera that shows a scene somewhere else in the map, like if you're following another character and you just see where they are, stuff like that. I use it now and then. That's other stuff that's in my engine, but a lot of this stuff is like debugging and stuff that really shouldn't be in there. Anyway, that's the DirectX side of things. And I know it seems I'm like skipping through it, but there's a lot of other stuff I want to talk about and just show you what it looks like. So when you really get down to it, when you're drawing stuff on screen, you're drawing probably in a 2D game one of three things. You're drawing a sprite, you're drawing a particle effect, or you're drawing text. And why is text not just a lot of sprites? The reason text shouldn't be just a lot of sprites of characters is that that's very inefficient. I use things called bitmapped fonts, and I don't know if you know what a bitmap font looks like. I wonder if I can get mine to just show up. Depends. Pack GUI fonts. I don't think they are going to show up, are they? No, because they're really heavily alphaed. Oh, how annoying. But basically you have like a texture with loads of characters in, right? So the reason I would say that text is drawn differently is with text, because you're drawing tons and tons of little characters. You imagine filling this screen. Well, I'll show you. Well, let's look at the game, right? Should we go to a text-heavy screen? No, maybe this. It's not that text-heavy, actually, is it? But if I want to draw this text, if each character being a sprite, okay, that would mean it's a draw call. So there'd be 1,000 draw calls or something for screen. It's stupid. So if you're drawing text, that is a perfect example of when you use vertex buffers. And vertex buffers is a way of drawing hundreds, if not thousands, of sprites that all share the same texture and the same render mode very quickly in one draw call, not 500 draw calls. Draw calls are slow. And arguably everything should be in a vertex buffer, and DirectX will kind of do a little bit of that behind the scenes anyway. But with text, it's essential. But the reason you do it with text is that because all of the characters are in a single sprite sheet, sort of texture, single texture, you know they're all going to be the same draw call, and you know that therefore they're all using the same texture. They're going to have the same effect on them and everything. So, for example, this text up here, this is a different font. So when I draw this screen, I have to draw that and that and that and that together and that together. And then I draw all of the other text together. So it'll be 2 draw calls to do the whole thing, the whole text. So yeah, you're drawing one of 3 things, right? You're drawing a particle effect, a text engine, or you're drawing a sprite. Again, why is a particle effect not just a load of sprites? Exactly the same reason. And I talked about particle effects in a separate video, but it's exactly the same system. But a lot of the time you're just drawing sprites, right? And to show you what I mean by sprites, this planet, that's a sprite. That planet, that's a sprite. The background, that's a sprite. Okay. It's a really old-fashioned term, and the more you say the word sprite, the weirder it sounds. This logo is a sprite. So I've got 1, 2, 3, 4 sprites on the screen at the moment, plus a load of text. So because they're all separate textures, there's no point in me trying to do any clever vertex buffer nonsense here. I know that's going to be 4 draw calls. 4 draw calls on the screen is irrelevant. Who cares? 100 is irrelevant. So a lot of the time you just want to draw an image on the screen. So you need a wrapper for a sprite, and I'm going to show you mine. And it's called Base Sprite because it's the basic. Again, when you look at this, you think there's a lot of work. No, it's not, because 95% of this is just legacy nonsense or stuff that I've used once and needed and I've left it in, right? But I'll talk you through it. So basically, I mean, when you think about it, right, whenever you see something like this and you think it's complex, it's not, because what matters is this. All that really matters in a class is the data. Okay, these are all the functions. This is the data. Okay, and that is all that really matters. And I'll tell you why. Because the only thing all of these functions are going to do is manipulate this data. That's it. They're going to do it in different ways. Okay, so that set UV will change part something here. Top will return a bit of this data. Place local fast will do certain things to this data, but actually it's really simple, because all I've really got here is one floating point that tells me the angle of the sprite. I've got the width of it and the height of it, assuming that all of my sprites are rectangles, which they are. I mean, that's almost everything can be done as a rectangle. Okay, so I've got the width and the height of the rectangle. I've got 4 vertices, so 4 corners of my sprite. So each one of them is a DirectX vertex structure. And I've got a little flag here to say, is it axis aligned? Now, if it's axis aligned, I mean the angle is 0. And here's the thing. Almost every sprite you draw on the screen will be axis aligned. Almost every sprite you ever draw will have an angle of 0, because you've got an image and you draw it on the screen. Now, okay, you're doing a game and a little character who spins around, and okay, fine. Some sprites rotate and spin and are drawn at an angle, but a lot of them aren't. And it's so much faster to manipulate the data if the angle never changes. Collision detection is a lot faster. Loads of stuff is faster and easier if the angle is 0. So I don't keep checking is angle exactly 0. I've got a little flag that says it's axis aligned. And I think I can set that. I think I do a set axis aligned or something, probably. It must be. Or do I? Maybe I assume it. I can't remember. Oh no, this is public, so I just literally say it. So actually a sprite is really simple. Okay. And if we look at drawing it, we look at the basic draw call for it. I do a little check to see if the sprite's on the screen. If it isn't, I'm not going to draw it. I'm not going to waste a draw call, right? I've got a check here that I shouldn't bother with because, I mean, why do this? Because I've really screwed up if we haven't started drawing a scene in DirectX and then I try and draw a sprite. So this will never trigger. I'm embarrassed to see this. I should delete it. This shouldn't be in there. So then I've got a thing called draw no checks because I can bypass all of this if I know it's on screen. Okay. So if I go to draw no checks, it's really easy. Look, it's that. It all makes sense. It's like Cliff planned the video because look, that function is the one I looked at earlier. So I'm just doing that. Okay. So essentially all a base sprite is 4 vertices and a function to draw it that basically just calls that DirectX wrapper and draws those vertices. Okay. That's all well and good, but that's kind of useless because you need to position, you need to set the height and the width of your sprite, and you need to place it on the screen. And I call the function that does that, I've got a lot of special cases, but basically I've got a function called place local, and this is it. And I'll talk you through it. So look, I'm using my clever axis aligned thing here to speed things up. To make stuff faster, I am caching. And when you hear the term caching, I don't know if you all know, caching means there is a variable bit of data that I'm going to use a lot, and it's somewhere else. It's over there. But I'm going to take a copy here because then it's to hand. So when you locally cache something, you're saving yourself a lot of trips. Okay, so I'm locally caching this calculation that otherwise I'd have to do a lot, which is half the width and half the height. I'm going to use those multiple times. So that's what that is. Okay. If the angle is exactly 0, or I've set that flag that means I know it's axis aligned, then placing the sprite is really, really simple. Okay. Because what this function does is it takes in X and Y. So this is the screen position of the sprite. So I just position the 4 corners. So we go, up and left, and then whatever, you do the 4 corners of it like this. So it's quite simple. So that just places the sprite by directly setting the values in those DirectX vertex structures. If it's at an angle, you have to do more fancy stuff because you have to use trigonometry, which you all enjoyed at school. You have to do like sine and cosine stuff in order to work out where it should be, and then translate it into screen space like that. But look, it's not complex. I mean, that's it. That's how to rotate a rectangle and put it on the screen somewhere, given that you know the angle, you know the height and the width, and that you know the position of the center of the object. That's it. Here's the thing that no one tells you, kids. If your sprite class was super simple and it basically just had this, and it had place local and draw, and that's it. That's it. You're done. Okay. A lot of the stuff here is because I want more functionality, right? So by default, when I set up a sprite, let me show you the basic constructor of this. Okay. So I'm presuming the angle is 0. I'm not saying it's axis aligned unless specifically set later, but whatever. So I use this little macro to set up each vertex, and I set it to this default color, which is white and not at all transparent, so completely opaque and white. And I'm setting up the UV values here so that it completely stretches whatever texture is set across the sprite. And that's it. Now I may want to change that, okay? So I may need to change the color. So if I have like set vertex color, I've got a version where you can pass in RGB values, a version where you can pass in my special wrapper for colors, or a version you can just pass in an unsigned long, which is, I think, which is basically what DirectX uses internally. And I just set all of the verts to be that color. So that's a little helper function to change the color, okay? The other thing that you might want to do is to set the UV values. And I've got various functions that do this in various clever ways for very specific cases. But basically, if you pass in the left, the top, the right, and the bottom for your UV, then you just directly set them on those vertices, and that's it. You can do texture atlases with just that one function. I've got other ones for texture atlases that make it slightly quicker and slightly simpler. If you know you've got like a grid system of like 10 by 10 different frames of an animation, for example, I've got little helper functions that make me do that, that let me do that easier. I've got a function that flips the texture up down, and one that flips it left to right, stuff like that, and one that just resets everything to what it should be. So it's not flipped. But really, a lot of this is just like helper function stuff. What I've shown you is basically all you need, right? So you have 4 vertices, and you have some helper functions that position them on the screen. But it's really simple. I'll show you that again, the draw. Okay. If it's on screen, don't bother. Are we in the scene? We're always in the scene. Draw no checks. If we're going to draw no checks, it's simply one API call. Okay. You could ship a game on Steam with just that, right? Very easily. But you will find over time that you will get to a situation where you end up adding a little bit of stuff. You might want to know where the top or bottom of a sprite is in order to position something relative to another sprite. If it's rotated, that's a bit of a pain. But if not, you're just returning a value of the bottom one. Same with left, top, whatever. And I think this is, looking at code like this is what puts off a lot of junior programmers from coding their own engine. Because someone will say, let me show you how to do sprites, and they show you this. And you think, oh, really? But a lot of it is just helper functions around a very simple core. And a lot of it is used only in very specific cases. And a lot of this stuff is just like handy ways of accessing this data without writing a load of other code, right? I mean, how often do I like copy the UVs of one sprite to another sprite? Not very often, but I've obviously had to do it once or twice, and I've added that code into my base sprite class. I bet I don't even do it in this game. No, I don't. So a lot of this stuff will not be even used. That copies everything that I'm using for engine glows. Okay, whatever. But it's pretty rare. So what I'm getting at is your sprite class can be quite simple. But you may be asking, what about textures? Because the sprite class doesn't even have any information about the texture. The vertices have the UV values of the texture, and you have the color that you're going to multiply by the texture color. But where's the texture? And I have actually followed my own advice in this, and I have a separate class for it. But I think. Oh no, I did move it. Oh, good for me. Because it used to be, where is it? Is it texture sprite or something? I moved it really, not for this video, but I moved it really recently. It's called C texture sprite, isn't it? That's embarrassing. Pick a naming convention. Anyway, whatever. So this is one step beyond that. So this inherits from base sprite. yes, despite what you've been told, there is actually a good reason to use inheritance in C++. It is not evil. Don't obsess on it. Don't inherit from 6 different things and 20 levels deep. But of course it's useful. It was put in C++ for a good reason. I have a base sprite, and sometimes that's all I want. If I just want a block of white, I can use a base sprite for it. Or if I'm setting a texture somewhere else and I don't need to bother the sprite with what the texture is, I will just use a base sprite. But a lot of the time I use a textured sprite so that they're split with one inheriting from the other. So this is a special case of a base sprite, a very common special case where it has a texture. And you know what I was saying earlier about don't care about the complexity, just look at the data. Look, it's really simple. So my textured sprite is just a base sprite with another object in it, and that's called a smart texture. You know, I name things randomly, you know. So let's look at smart textures. So a smart texture is basically, again, look, all it is it's this. A lot of ways of manipulating it, which is handy. A lot of code, well, I mean, all code is just a way of manipulating data. Here's the data. This is what matters. These are various things that let me do various things to that. So the smart texture is basically a wrapper around something else, which is a loaded texture. And if I look at this, what it really is just a pointer to a DirectX surface. Okay, well, a texture. And I've called it psurface just to confuse you. Anyway, so you might be thinking, well, what was the point of the smart texture if all it contains is a loaded texture? But it doesn't. This is really important. Okay, this is not an object. This is a pointer to an object. Okay, if you're new to programming, back in the day when I learned C programming and C++, the one thing that everyone said is pointers are a nightmare, aren't they? Aren't pointers hard? Okay, and whole languages exist without pointers. But when you're used to using pointers, it's like you know, it's just like the alphabet. It's just a simple thing, right? So a pointer is the address in memory of an object. Okay, so you have an object somewhere, like I have a packet of biscuits in the cupboard. That's the object. If I want to refer to that packet of biscuits, I have a pointer to it. So so I can access it through that pointer. I know the address I know where in the cupboard it is. Okay. And the thing is, if I was sharing this house with 20 people, they could all have the address of the biscuits. They all know where they are, right? So we've all got like information about where the biscuits are. I know this is slightly patronizing, but I'm hungry. But the important thing is that there is only one packet of biscuits. Okay, so you're not duplicating anything. And so you can all access this object, but you do so with an incredibly small memory footprint, because the address of an object is just a handful of bytes, whereas the object may be huge. It may be a huge complicated thing. And that is important. So here I have a pointer to a C-loaded texture in my smart texture. And if I look at the C-loaded texture, ironically, it's got a pointer because DirectX won't let you have stuff. DirectX has the texture. DirectX is managing that texture, okay? It will let you have a pointer to it, okay? And I have this object that manages that. And all this really is a way for me to attach a string, a name, actual human readable text to that pointer. So I can, for debugging, this is invaluable. Okay. And so that I can very easily sort of check what it is. Okay. But why this difference? Okay, there is only one DirectX texture, and you know, I've got a pointer to it here. Why do I have this other class that sits on top of that? And the reason for that is this. Let's say that your game is about reindeer, okay, and so you have an image of a reindeer that is that character, that sprite that you draw on screen when you want to draw a reindeer. But there are 200 reindeer in the game, and sometimes they're on screen, sometimes they're not. So you've got 200 sprites that all need to be drawn with the reindeer texture. Okay, you don't want to load in that texture 200 times. It's pointless. It's the same in every case. So what I have is a C loaded texture, which is the one instance of that. It's the one way to talk to the DirectX version of that. This is the one example of that reindeer texture in memory. And my 200 textured sprites will each have one of these, which is just a pointer to that. So if I want to draw that sprite on screen, I can go through and draw it, but there's still only one of them. And if you create under 600 reindeer objects, we haven't loaded the texture in twice. There should never be two copies of a texture in memory, right? Because it's the same. You're not writing to it, apart from very special cases. So if we go back to the textured sprite, let's say I draw it. I want to draw this object, right? Again, it calls draw no checks, which is inside the other function. So that goes back into base sprite, okay? But before it does that, it calls stset. That's my smart texture. And that set function, again, goes through the pointer to the only one copy, the C loaded texture, and it calls set on that. And that actually uses another class, which I'll talk about in a minute, called the texture manager. But for now, just accept that when I do that, it calls this. Get D3D engine, which we started with, get the device, which we do everything through, and it sets that texture to be the current texture. I also kind of like log what textures I've set for debug purposes. If I need to look at it, I can put a list on screen. It's pretty simple, huh? There's a special case down here if this pointer is null. Sometimes you want the texture to be nothing, okay? And that takes a little bit of management. I'll talk about that class in a minute. Hopefully that made sense, right? So again, we're going to go back to the class we will use a lot, which is a C textured sprite. I'm going to draw it. So in that, the smart texture called set, and that goes to the single case, the C loaded texture to call set. That calls the texture manager that calls set, and that gets the direct 3D engine device and calls set texture. Now, if you're thinking, what? That's hundreds of draw calls deep, right? This is actually quite normal. In fact, this is really, really shallow. If you, I worked on two big worked with, sometimes on, two big graphics engines at Elixir and Lionhead. And when you're trying to work out when something's gone wrong, and you put like a breakpoint really at the bare metal where you call a DirectX function, and then you look at the call stack. I'll tell you what I'll do. I'll prove it to you. I'll show you. Examples are better. Okay, that needs to be off screen. So I'm just going to, I'm going to draw something. I'll show you the screen. This is the screen. Okay. Now I'm going to move it. And I'm going to put a breakpoint on set texture. Okay. Hit instantly, obviously, because we're doing a lot. I just want to check. Can you, right. Okay. Oh, no, I can't do that. Okay. Here we go. It's a bit hacky. Here's my call stack. Down here. I presume you can see all this now. So yeah, we're in WinMain. We're in the game proc. I talked about this stuff before. We're in a specific game modes game proc. I'm in the level choosing mode, drawing that screen. It calls a window manager to draw all of the various windows on that screen. There is only one window in the window manager at the moment, which is the level chooser interface. It's drawing a sprite, which I think is the background sprite for this screen. So there we are, see textured sprite draw. There we are. And it goes through that smart texture to there, and to there. And if we were to go into this, I'd lose it because we'd then be inside the DirectX runtime. Does that all make sense? I hope it does. Right, let's remove that breakpoint. Yeah. So to remind you, we were drawing this. Right, let's get rid of that. Okay, hopefully that made sense. So the last thing I'm going to talk about is texture management. Okay. Again, separate stuff, put stuff into separate classes. So I have a whole separate system to manage textures called the Texture Manager. I got one other thing I was going to talk about. Leave me alone. I'm doing a video. Oh man, someone wants me to play Battlefield 6 urgently. This is so unprofessional. This is why I'll never be a proper streamer. Anyway, whatever. I'm going to very quickly talk about texture managers, and then I'm going to talk briefly about a system I use, like a render management system, what some people call scene management, and then I'll stop because I'm going on. So I have a texture management system somewhere. Where is it? Here it is, Texture Manager. Okay. Again, it looks complicated because there's a lot of functions that are helper functions, but really it's actually quite simple because it comes down to this. Okay, this is going to really freak you out if you're new to code. This is a pointer to a pointer because you can do that. So a G texture 9, which is this up here, it's an actual structure. And I have I have an array of them. And because I've got an array of them, I need a pointer that I can manipulate the array with. So I need a pointer to a pointer. So I need a pointer to an array of pointers. I know it's a bit much, isn't it? Okay, the reason I'm doing this is what this class is, and I'm going to only vaguely touch on it. But what this class is it's basically a big list of all the textures that I have loaded, okay? But it's not a list. The reason it's not a list is that when you want to grab a texture from that list, you want to do that a lot in a game probably. And because of that, you don't want to be going through a list, okay? And the thing is, at runtime, I am not very often adding new textures. I know what textures I need and I load them in, and then that's it for that level or whatever, or that screen or whatever. So what I do is I create an array of all of those pointers, because nothing in the universe, not even my car, is as fast as accessing something in an array. It's incredibly fast. So that's why I do this. It's basically what this is a class that manages all of the textures in the game. It's as simple as that. One thing I should point out, if I go through the hierarchy here of actually creating a texture, blah 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 blah, is create texture manual. Here we go. The file format I tend to use is DDS, which is a direct draw surface. You need a special plugin for stuff like Photoshop, I think. I'm not sure if it does it natively now, probably does. But the reason I use DDS files is that they are exactly the format that DirectX wants. And if you upload, something else, it will convert it. It used to convert it into DDS. Probably do PNG natively as well. I'm not sure. I don't know about JPEG. But I think, why not work with exactly what the graphics API is expecting? But interestingly, in DirectX 9, the helper functions written by Microsoft for loading in DDS functions were abysmally slow. Now, you don't notice it unless you load a lot of textures and you're really obsessed with performance, but they were really slow. So I wrote my own, and it was like laughably faster. But what you really want to do is you just want to load the entire thing into RAM and then load it from RAM. for various reasons. File writes are really slow. Okay, this is why people use pack files. If you have like 500 textures in your game, and they're all small, and you load in 500 textures, overwhelmingly what that code is doing is it's doing operating system level bullshit. So it's kind of like, do you have permission to access the file? I am preparing to open the file. I'm notifying everyone the file is being opened. Oh, here comes the virus scanner to check it's not a virus. No, it's fine. We are now opening the file. We are now reading the file. We have finished reading the file. We are closing the file. The file is now closed. And it does that 500 times. The actual loading in of the pixel data is actually quite small. So if you possibly can, use texture maps or a pack file. I've got a pack file system, and use that instead. And this is why you should have manager classes that do stuff. My texture manager handles all of this stuff of loading in the different file formats. But what it also does is it gives me a place to interface with my own pack file system, stuff like that. There's also one place where I can release all these textures, or release a specific texture if I know it's a big texture from a previous screen I don't want. What I'm getting at is write code like this. It doesn't have to be exactly this. Don't try and stick all of this in your one graphics engine class, because all of the stuff to do with textures is to do with textures. Okay, it doesn't have to be in the same thing. The last thing I'm going to talk about, and I know I'm really kind of like racing through a graphics engine thing, but I'm talking about the concepts more than anything. I started changing the way I render everything for this game just because I can't leave anything alone. And I'm not even sure what it is. It's called like Render Manager or something. Here it's Render Manager, yeah? So like in an ideal world, you would never do anything redundant in a graphics engine. So say I'm drawing a sprite and it has a burn blend mode, which I've talked about before, and it has a particle texture, and I have a sprite for it, and I do a draw call through a textured sprite to draw that. Okay. If the next thing I draw has the same texture and the same blend mode, and then I draw that was a waste of a draw call. So what you should do is do stuff lazily. Okay. And what I mean by lazily is you pretend to do stuff, but you're really just making a note of it. So, and lazy execution is a brilliant concept to get your head around. So when I draw that first sprite, I'm saying, okay, so I want to set the blend mode in DirectX. I want to set the texture in DirectX. And then I want to render these vertices. Okay. But you don't do any of that. What you do is you sort of go, next time we render, I'm going to set this blend mode, and I'm going to set this texture, and I've got these vertices here. And then if I go to draw something and any of that's changed, I can go back to my lazy list and go, okay, everything's changed. I better do those other things first, and it draws them. Because when you're drawing everything on screen and then it flips and you show it, okay, it doesn't matter when in that next frame you draw something, as it were. When you want to draw something, it doesn't have to be right now. As long as it happens before the next frame, it's fine. And as long as it happens in the right order, it's fine. So you do stuff lazily. So what I do is I don't, although I've explained to you how my sprite system works, that's not actually how I'm using it anymore. So for a lot of the case, if I think it's a complex screen with a lot of stuff going on, my game, then what I'm actually doing is I'm adding entries to this list instead. So I'm saying what kind of primitive it is. It's normally a sprite, so it's normally like a loaded texture or whatever. It's normally like a textured sprite, or it might be a base sprite. So I'm passing in one of these. I'm passing in a pointer to whatever that is, one of these two things. I'm saying the render mode, and I'm saying the texture. So if I look at that, I've got code here that sort of says, has anything changed? Okay, if anything's changed, render. In other words, flush the current list. Okay, But if nothing has changed, if we're doing another example of the same thing, then just make an entry in my list. It's called pending entries. And if we look at render, all that does is it goes through that pending list. It sets the appropriate blend mode, and it goes through and it draws them. It actually uses a different function called draw to vertex buffer, because I collapse all of these draw calls for these different sprites that are the same into a single draw call using a vertex buffer. If you want me to do a whole video on vertex buffers, I will. They're kind of cool. I mean, they're brilliant. I mean, they speed things up unbelievably. But the important thing that I'm trying to get across here is just the principle. Okay, so the principle is lazy execution. Execution means doing something. So what I'm saying is never draw anything. The ultimate graphics engine is laser focused on never doing anything. So all you ever say is, this is the kind of thing I need to draw now with all its relevant data. This is the kind of thing I want to draw next. And only when they conflict do you go, okay, now I need to do a draw call. And sometimes, depending how things work out, this pending entries list will only have one thing in it, and then it'll be immediately emptied. And in that case, we've had very slight overhead of creating an entry in a list that's immediately emptied. Tiny. Okay, but a lot of the time, there will be 10 or 20 or 30 or 100 things in the pending entries list. And then we've collapsed like 100 draw calls into one. It's really helpful. I hope that made sense. Graphics engines were like a massive topic and I've skimmed through it. But leave me a comment if you want any clarification on anything. Oh, and also let me know what you would like me to talk about, what you're interested in, or what you're not interested in, or does it need to be more complicated than this? Do you want to go more in depth than this? Do you want me to do a thing on profiling? I love profiling. I profile for fun. The only reason I won't spend Christmas Day profiling is because I have relatives. Anyway, I hope this was interesting, and if nothing else, all my blathering on, you can at least see a lot of the code and look at it and freeze frame and go, oh, okay. Anyway, I quite enjoy making these videos. I don't know why. But anyway, thank you for watching, and I'll probably do another one just in the new year. So let me know what you would like that to be about, and thank you for watching, etc. Blah, blah, blah. Oh, and happy holidays.